Let's now talk about how we can generalize beyond lowercase English words and do something a little more sophisticated. So I think it should be clear that only being able to support lowercase English characters is not great, because we might want to store strings like Tupac or this strange string E, capital G, lowercase g, exclamation point. So the only difference, it turns out, that's going to be significant is we're going to change our base. So instead of using a small base, like say 27, we're going to need something bigger. So to get there, let's discuss very briefly something known as the ASCII standard. So the most basic character set used on computers around the world is the ASCII format. And essentially, it says for every possible character out there, like say exclamation point or pound sign or single quote, there was a corresponding number representation for that character. And this goes way back to the telegraph days. So it's just some arbitrary standard that was created. Now here I'm only showing the characters between 33 and 126 because those are the so-called printable characters. The other characters do other things. For example, one of them is the new line character that represents a line break. Now, as an example of how this interacts with Java, if we look at a piece of code that says something like char c equals single quotes d, well, this code, it turns out, is just shorthand or equivalent to saying char c equals 68. Now, why is that? Well, in the ASCII table, if we look at the letter D capitalized, that's the number 68. So these two pieces of code are effectively the same. And, by the way, that's why the letter to num helper function in the previous video made sense. So, now that we know this secret, that the largest possible character is 126 for ASCII, if we wanted to guarantee a unique value for all possible strings that are ASCII based, we would use base 126. So for example, B would be, in base 126, 98. Why 98? Because that's the letter B, 98. E would be 101 times 126. And then the second E is 101 times 1, which gives me a much larger value than we got before. In this case, a little over 1.5 million. Tupac has a numerical representation, and egg has a numerical representation. And they're guaranteed to be unique for all different ASCII strings. Now, the corresponding implementation for this turns out to be even simpler than our English to int method we had before. So now, because we're using the raw character value, that is the official ASCII values, we don't need a helper method to convert, for example, the letter B into the number 2. We just use whatever the letter B is. As we said before, that's 98. So this is a very short function, ASCII to int. And the only difference here is we're not using a helper function, and we're using base 126. Now maybe you want to go even further, go beyond ASCII, and you want to support other languages, like say Chinese. Well, it turns out that characters in Java also support character sets for other languages, like Mongolian, Chinese, whatever else out there. And this looks terrible. It looks good in the editor. But anyway, in the rendered version, okay, I can barely read it, but eh. Now it turns out if we do character C equals ao, I think that's right, that's the exact equivalent of saying character C equals 40,140. So this encoding that covers all possible character sets out there is known as Unicode. I'm not going to say anything more about it in this class. The table is too big to list, but be aware that this is possible in Java. So now, if we wanted to support Chinese characters, and we want to represent all possible strings of Chinese characters uniquely, we need to know the largest value. So it turns out the last character in Unicode that is a Chinese character is this, whatever that is, which is 40,959. So as an example, we have this word here, which means goalkeeper, and if we're doing base 40,959, I think that's what it means at least, in base 40,959 ends up being somewhere around 39 trillion. Okay? And so now if we think about what that would look like in a data index set, we would basically have a separate, unique, false or true entry for each possible string of Chinese characters. So now this is starting to get a little out of hand, and so I'm not going to say, oh wait, actually, yes, okay, I see. I did Chinese style here and American style here. Anyway, so here you can see things are starting to get a little out of hand, and we'll see that things are actually even worse than they appear. And we'll talk about that in the next video.